Hello students, we will start our next video of physics class 10. Okay, so this will be our fifth video. Chapter 1 physics. Okay, so date. So in the previous video we have already discussed about the different equilibriums, that is our static equilibrium and dynamic equilibrium. Also we have checked the condition of equilibrium. Fine. So today we will discuss about the principle of movements. Okay. So our today's topic will be principle of movements. So principle of movements states that you can just remember the definition, the sum total of all the movements. So in book or two definition are there, it's up to you that which one you want to remember it. Okay, so this definition is easier to remember, so you can use this definition. So principle of movement states that the sum total of all the movements about the turning point is 0. Okay, sum total of all the moments of the turning point about the turning point is 0 when a body is in equilibrium. That means if the body is in equilibrium, then sum of all the movements about the turning point, that will be, it may be your clockwise movement as well as anti-clockwise movement, all will be 0. Okay, so you can see the first definition also, page number 6. Okay, so if a number of forces acting on a rigid body kept at equilibrium, then the sum total of clockwise movement about the turning point is equal to the sum total of anti-clockwise movement. This can be also be written as that sum of clockwise movement is equal to sum of anti-clockwise movement only if the number of forces acting on the rigid body keeps it in equilibrium. That means if the body is in moving, then it will continue in motion, or if it is in state of rest, then it will be in state of rest. Okay. Fine. So our next topic is our center of gravity. Center of gravity. Okay. So what is center of gravity? It is a point within a body. It should be inside that body, within a body, where the whole weight of the body is supposed to act. Okay, suppose we find any point inside a body in which the whole weight, or at that point we can fully balance that body. That point is known as our center of gravity, or we can say center of mass also, CG. Okay, in short it is written as CG. So we can write that center of gravity, it is a or you can say it is a point within a body where the whole weight of the body is supposed to act. So this will be the definition of the center of gravity. Okay, and if we consider the suppose here we have considered the weight, so if we consider as mass, then it is said to be center of mass. Okay, so you can write that if we consider the mass of the body, if we consider the mass of the body, if we consider the mass of a body is concentrated at that point, at the point where the whole weight of the body acts, then that point will be known as center of mass. Then that point is called center of mass. So you can remember this also. So there are a number of ways by which we can determine the center of gravity. Okay, so all of you need to open the page number 7 of physics book class 10. Okay, so you can see that section 1.8. So question is that determine the determination of center of gravity. The first one is for regular bodies. Okay, for regular bodies means whose shape are known, such that your triangle, rectangle, then ellipse or circle or square or cuboid, something that the whose geometrical shape are definite. Okay, so if that definite shape is given, then how to find that? Suppose one example is there for regular bodies. For regular bodies they have taken a rectangle or square or parallelogram. So how to find the center of gravity? Just join the two diagonals. So the point of intersection of the diagonal will give that center of gravity. Okay, so you need to write all these points in the copy. Second one is your triangle. So how to find the triangle? For triangle, it is the point of intersection of its median. So you have to draw the median from every vertex. So how to draw the median of every vertex? Suppose we take one rectangle, not rectangle, triangle. So from this point, suppose from A, we draw one median. How to draw the median? Opposite face. So opposite face is our BC. So we have to take the midpoint of BC. Suppose this point is a midpoint of BC. So we have to join A and this midpoint. So this is the median. Again from B, we have to draw median on AC. Suppose the midpoint of AC is this one. So again join this. And again from C, our midpoint on AB will be like this. Okay, so this is the point of intersection of all the medians. So this point will be our center of gravity. Okay, third one is the center of gravity of a cylinder. How to find the center of gravity of cylinder? It is very easy. It is the center of its axis. Center of its axis means, suppose we have one cylinder, its axis will pass through its center. So the midpoint of this axis, suppose this length is 10 centimeter. So its midpoint will be at the 5 centimeter. So this point will be our center of gravity. It is the center of its axis. And for sphere, it is the geometrical center. Geometrical center will be our center of gravity for any spherical shape. Okay, so these are for any regular bodies. Now for any irregular body, how can we find it? Okay, so for that we need to do one example, or yeah, we need to take one experiment. So you just read this experiment. Okay, experiment number on page number 8, figure number 1.25. okay, so after reading this, if you find any issue, then you can contact me. Okay, just read that. If you find it difficult to understand, then kindly contact me. I will again make one video on this unit. Okay, and some question may be asked that whether it is necessary that the center of gravity will be within the body or it is everywhere inside the body. The answer is no, because we have seen in triangle it is inside the body, we have seen in sphere it is inside the body, in the cylinder it is inside the body, but it is not necessary that center of gravity is always inside the body. So in examination they may ask you some question that is it possible to always find a body whose center of gravity is inside it? No. So you can see, you can give the example of our figure number 1.26, that is boomerang. You have seen this stick in TV, boomerang. Okay, so its center of gravity is outside the body. Okay, so figure is not perfect, so its body is outside, its center of gravity is outside. So question may be given that give one example of a body in which the center of gravity is outside the body, so you have to write that it is boomerang. Okay, so any L-shaped body has its center of gravity outside its body. Okay, so in the next video we will discuss about the uniform circular motion. So till that, you just clear all this thing. Okay, so within 1 or 2 videos we will complete this chapter, and after that we will discuss the exercise and solve the numerical problem. Okay, thank you.